Hello, Jillian. This video is just for you. This is what you missed the day we came back after final exam. So there were some common errors, like lots of people made them, like probably half of the people made these same errors, more than half in some instances, like number 1. So I invented these true-false statements to see what people's conceptions were, and I'm pretty sure I knew what they were, but here's the first statement. If the second derivative at a value is equal to 0, then there's an inflection point at that value. Well, this is not true. This is false. I thought I sent you this in an email, but maybe I didn't. False, because not only does there have to be a 0 value there, no concavity, but it also has to be a change in concavity. So what I recall was this problem on the final had 2 critical points. I think they were at 0 and 2. The second derivative test is appropriate here, but you have to continue the test. It's not just finding those critical points, but noticing, oh, concave up, concave down. So there really was only one inflection point because there was only one place where there was also a change in concavity. Number 2 here, the second statement is also false. E to the x, struggling with this a bit. E to the x, for those of us who tried to factor and had a factor of e to the x and something else like x plus 2, finding those critical points, a lot of people thought there was a critical point here from this factor and here from that factor, and that is totally wrong. Here's a reason why. E to the x, that function is exponential growth. It will never equal 0 because there is a horizontal asymptote at y equals 0. Again, the output of e to the x is never 0. Even if you have a negative exponent, e to the negative 5, for example, that's just a number less than 1. It's 1 over e to the 5th. So this is never going to be 0. And the third and final statement seems like it would be false, and it is. Another false statement here. Movement in the negative direction does not mean that you subtract from total distance traveled. Distance, big idea here, distance is never negative, and we've started to see that hopefully in our AP free response packet, that first bundle of problems that was distributed. This is totally false, and let me just try to act it out a little bit without you seeing me. Here I am. I'm going to walk forward about 6 steps. I'm going to walk backward about 10 steps. So here I am now. If you subtract this distance that I traveled forward and backward, it's like I only traveled backward. However, if I were wearing one of those pedometers or step meters, whatever those are called on your watches nowadays, I would be recording steps, movement forward, movement backward. So I would have 6 feet forward, 6 feet back, and another 4 feet. So that would be a total of 16 feet traveled. It's all movement. It's all distance tracked on my legs. Distance will never be negative. Do not subtract that distance, even if it appears to be negative based on velocity. That just says you're traveling in the other direction, but traveling nonetheless. Here's what we talked about as our slightly new topic, I guess, after final exams. These two integrals appear to be similar, but they're very different. The very first thing I asked people to discuss in class, and some people discussed it, and I'll pretend I'm discussing with you. A definite integral will definitely have a value to it. It has an interval, it has values like at the boundaries for A and B. Oh, what'd you do on Friday? That's what we talk about too sometimes when we discuss. Okay, back on target. Indefinite integrals do not have a value because there are no boundaries, there are no interval endpoints A and B. So for an indefinite integral, you will have a general solution that you write. Basically, you're just finding the antiderivative, and that's very much the case here with this problem on the right. That is an indefinite integral. I do not plan to have a number answer, a value. It will just be another function, basically. So Good talk. There is a difference between definite and indefinite. This first one is definite. There will be a numerical value here, and I feel like we could do this problem right now. We are going to do it. I'm going to rewrite the square root as a 1/2 power in my mind, and then I'm just going to use algebra. Do you remember algebra? This would not be a problem for u sub. I hope we're realizing that even if you called that quantity inside the parentheses u, there is no relation or direct connection to the square root of x. That is definitely not our du. So if we use algebra, we would have x to the 3/2 power. I'm just rewriting the problem, minus x to the 1/2 power. And if I tried to find the antiderivative of that, I could do it very easily. X to the 5/2, 2/5 of that, minus x to the 3/2, 2/3 of that. And I could then evaluate from 4 to 9. The upper boundary first, I would have 2/5 of 9 to the 5/2 minus 2/3 of 9 to the 3/2. Whatever value I get here, I would be subtracting, and I like to put the whole thing in parentheses. 2/5 of 4 to the 5/2. I'm regretting these boundaries that I've chosen. Minus 2/3 of 4 to the 3/2. We will get a value. A person should know that this is the square root of 9 being raised to the 5th power. So that would be 3 to the 5th power, which is about 243. Doubled is 486. Those are fifths. 9 to the 3/2 power means the square root of 9 being raised to the 3rd power. That would be 3 cubed, which is 27. And times 2/3 would be 54 thirds. And I'll leave these in fractional form for a moment. 4/5, 4 to the 5/2, square root of 4 to the 5th power. That would be 2 times 2 times 2 times 2 times 2. And that comes to 32, which would be 64/5. 4 to the 3/2, square root of 4 cubed. That would be 8 or 16 thirds. Now as we subtract here, we're subtracting this number, but adding this number if you distribute. The double negative there is causing us to add. And now I'm looking at fifths and thirds, and if I put it all together, I should get a fairly nice answer. Or not. We end up with 15ths here. And it's 1076. 15th. Ew. Well, that's the accumulation nonetheless. And we powered through that. We just need to get a common denominator and be able to handle a 4-digit number. That was not a case for u sub. The second problem, though, on the right here is. So I've cleared some space, and now I have room to work through this problem. Now this is an illegal math move if you tried to distribute the x into the radical, and I don't know why you would want to either, because then you'd have square root of some quantity, probably x cubed if you did it correctly. Okay, so not going to do that. We will do a u substitute here, and watch how this works. This one's very different from some that we've done. If I call u x plus 1, which is pretty natural, the quantity under the radical, then du would be dx. Both of those quantities are here and replaceable. Something that we have not replaced, though, is x. However, x is closely related to u. So what we're going to do here, this is called a double substitution. We're going to use the substitute twice, essentially. I will express x in terms of u. So in this statement that I've created, u equals x plus 1, if I subtract 1 on both sides, I have x. And x then is u minus 1. So here I will rewrite x is u minus 1. And then we have the square root of u, which is what we call that radical quantity. The x plus 1 is u. And then I have du. Notice it's an improper integral. It stays improper. I'm not going to invent any boundaries. And now this problem is darn near close to, or exactly the same as, actually, the one that we just did. So I would have the square root of u times u. I could use algebra now. This would be u to the 3/2 minus u to the 1/2. Haven't found any antiderivatives yet. But this structure was revealed by the double substitution. So if I keep working with this, I'm going to find the antiderivative now. It would be u to the 5/2, 2/5 of that, minus u to the 3/2, 2/3 of that, and don't forget in this case plus c. Because the problem was originally given as a function of x, we should probably find the antiderivative also as a function of x. So I will replace all u's with that x plus 1. So here's our final answer. This indefinite integral has a antiderivative or general solution of 2/5 times the quantity x plus 1 to the 5/2 minus 2/3 times the quantity x plus 1 to the 3/2 plus some constant unbeknownst to us. And there's our final answer. So a double substitute was required there because even after we replace u and du, something else could still be written in terms of u. Here's a problem for you to try. Maybe you want to pause the video and try it for yourself. This one does get kind of interesting with fractions. Again, pause the video, try it, see what comes of it, and then you can push play. Do, 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 do. I'm waiting for you to try it. Do, do, do. Okay, now see how I did it. Did you call u 2x minus 5? Hashtag same. Did you call du 2 dx? And realize that 2 was not there, so then you needed half of du. If I rewrite with what we have something over the square root of u, and then we have du and the multiplier of 1/2. Again, because we did not see 2, we only have technically a 1 dx there. Replacing x. X could be written in terms of u. X, if we solve, would be u plus 5 all divided by 2. And so I will replace that here. It's going to look funky for a second. But it might be easier if a person were to factor out this 1/2 here. Dividing by 2, doing all of that is the same thing pretty much as multiplying by a 4th. Or like I just said, we're factoring out this 1/2 denominator here. Then I simply have u plus 5 over the square root of u. We've used the substitute twice. We're not going to use it 3 times. This is not a situation where the denominator is a different u and the numerator is the du. This is totally not a logarithm. But I can use that algebra to rewrite this. If I divide all of these quantities by the square root of u, I'm basically trying to find the antiderivative of u to the 1/2 plus 5u to the negative 1/2. Dividing each quantity separately, that is u to the 1 divided by u to the 1/2. And then I also took the 5 and divided by the u to the 1/2. Square root is the same thing as a 1/2 power. And now we can find the antiderivative by simply applying power rule in reverse. So we have u to the 3/2, 2/3 of that, but also multiplying by this 1/4. Maybe I'll show both. We'll figure out that constant in a second. And then we have u to the 1/2. And then it would have been 2 of those. So there's a 5 there. I'll do 10. Don't forget the 1/4 is still here also. Plus c. Final answer shall be written. Here it comes. Let's call that 1/6, replacing u with 2x minus 5 to the 3/2 plus a 1/4 of 10, probably call that 5/2. And u is 2x minus 5 plus c. Another situation for a double substitute. We use the substitute twice. And then after some algebra, the power rule in reverse. This is Mrs. D signing out.